This is the Your Turn number 1 in section 4.4. This question is asking us to determine the equation of the tangent line to this function y equals the square root of x minus 2 at the point x equals 11. So we know how to determine the slope of the tangent line. We are going to calculate the derivative. And when we calculate the derivative, we're going to calculate the derivative at the x-coordinate 11. We know that if x equals 11, we can also find its corresponding y-coordinate. So if y equals the square root of x minus 2, substitution of 11 will give us square root of 9, which is 3. So we know the coordinate that we're interested in is 11 and 3. So let's go ahead and determine the slope of that tangent line. So we're going to use the definition of the derivative, which is f prime of x equals the limit as h goes to 0 of f of x plus h minus f of x divided by h. So when we do our substitution for f of x plus h, we are replacing x with x plus h. So we get the square root of x plus h subtract 2. Then we have to subtract the f of x, which is the original, which is the square root of x minus 2, all divided by h. Now, if we try to calculate the limit right now by plugging in h to be 0, we'll get 0 over 0. So we know we have to do something to this limit to make it work. And we're going to use conjugates since we're dealing with radicals. So we're going to multiply it by x plus h minus 2 plus the other radical x minus 2 to the numerator and the denominator. It's the same thing as if you're multiplying by 1. Okay, so now we're going to start multiplying. And when we multiply out our terms, we're only going to multiply the terms that have the conjugates, which is the numerator. So if you multiply out the first term, you will get x plus h minus 2. The middle terms cancel. You will get x minus 2. The radicals are gone. And then the denominator, we'll just rewrite it as h bracket and x plus h minus 2 plus x minus 2. Okay, so now our goal is for h to cancel. So we'll simplify this by looking at the numerator. So the x's will cancel. The subtraction with the negative will make that 2 positive, so the 2's will cancel. So you notice you're just left with h, which is great because then the h's will cancel. They're both monomials. When the h's cancel, we are left with f prime of x equals the limit as h goes to 0 of 1 over the radical x plus h minus 2 plus x minus 2. So when we calculate our derivative by using the limit, we're going to substitute h to be 0. And we know we'll get the root of x minus 2 plus the root of x minus 2, which is the 2 root x minus 2. Now this is the slope of your tangent line for any x value. But I want the derivative for when x is 11. So I'm going to go back and substitute in 11. And I will get square root of 9, which is 3, and 3 times 2 is 6. So the slope of the tangent line at the point x is 11 is 1/6. So now the last step is to find the equation of the tangent line. Now remember, your point that we're subbing in is 11 and 3, which is like your x and your y value. So if we use point slope form, y minus y1 equals slope x minus x1, we will get the y-coordinate is 3. We just found the slope, which is the derivative, to be 1/6, and the x-coordinate is 11. And this is fine to leave it in point slope form. If you wanted to multiply it out and get the slope intercept form, you would get 1/6 x minus 11 over 6. And when you add 3, you would have to get a common denominator, which would be 6. So this is over 1. So if you multiply this by 6, you'll get 6. Multiply this by 6, you'll get 18. And negative 11 plus 18 would give you 7 over 6. So slope y-intercept form or point slope form is fine to write the equation of the tangent line.